Okay, we have a few learning goals over here today. Let's look at them. I can identify place values in decimal numbers. Okay, I don't know how good you are at that yet, but we need to be good at it. I can write fractions as decimals. So in other words, every fraction has a decimal name also, and we have to know how to go between them. We have to be able to make a fraction into its decimal name. And the last learning goal we have today is I can take a decimal number and I can rename it as its fraction number. So we have to be able to rename, to understand that every number on that number line has several names. Every number has several names. In fact, can you give me an example of some other names for 2, the number 2? Give me another name for 2. Go ahead, Wade. Can't hear you. Can't hear you.
Never mind.
Oh, okay. 2. Can anybody come up with another name for 2? Because it has a bajillion. Just pick one of those. Danny? 1/2. Is 1/2 going to live at the same place on the number line as 2 does? Somebody tell me where 1/2 lives at on the number line. Carly? In the middle of what? The middle of the number line 1/2 does? Oh, we got to be more specific than that. Right between 1 and 0. So here's where 1/2 lives on the number line, right here. Right here. Where does 2 live? In the same place? No, 2 lives over here. Oh, so that can't be another name for it then, can it? Because if you give another name for a number, it has to reside at what I call the same location, the same address on the number line. So let's try it out. Now, 2 over 1. 2 over 1 is another name for 2, because if you take 2 and you divide it by 1, what do you get? How many 1s are there in 2? 2. Or what does 2 over 1 simplify to? 2. So 2 over 1 is another name for 2. Can anybody come up with another one? Okay, another name for 2. We got 2 over 1. Sophia? 4 over 2. Dan, anything you got one now? That's the one you wanted? Okay. 4 over 2. Remember there's a bajillion. We've only named 2 of them. Wait. That's the one that Sylvia maybe should say it loud enough over here. 4 over 2.
It's 6 over
6 over 2? Is 6 over 2 another name for 2? No. 6 over 2 is another name for 3. 6 over 2 simplifies to 3. You got one now, Danny? You have a question? Is 0.2 another name for 2? What do you guys think? Do you think 0.2 is another name for 2? No, because what is 0.2 really? Kayla, do you think you know what 0.2 is? No? Hayden? Oh, you're going to still give me another name for, okay, you're going back to the original. We stick with the fact that right now we're trying to decide if 0.2 is another name for 2. What do you think, Wade?
No, that would be 2/10.
That would be 2/10. And is 2/10, where does 2/10 reside on the number line? Anybody know where 2/10 is at on the number line? At 5? Okay, so, pardon? Right before the 2? So you guys, right now, I'm starting to get a picture of, we need to be tuned in today to what the lesson is. You need to be engaged here because you are not understanding the number line and different names for numbers, for values on that number line. So today, we're going to do some of that hopefully will be better by the time we're done here. Okay, so decimals. Let's talk about place values first. Okay? So I have this number written here. Oftentimes, this is how people will say it. 3.0625. Now, I used to be just horrible. I never would let anybody ever say that. And then I decided, you know what? The world's not going to end if they say 0.0625. So, we're going to explore, though, how should we really see it? Okay? So, what place is the 3 in? So, right there, right before the decimal point, what place value is that? Okay? Is it in the tens place? 3. 3 of something. Hundreds. Or not? Hundreds?
Yeah.
Hundreds. Oh. Sam? Thousands. Thousands or thousands? Thousands. Okay. So far, nobody's right. Sorry.
Maybe 1.
Oh, it's in the ones place. It's in the ones place. Let's write that right here in this blank. That 3 is in the ones place. 3. It's in the ones place. There are 3 ones. Okay? Now we're going to move behind the decimal point and we're going to say, what place is the 0 in? Sam? Did I just give the answer when I called you by that? Okay. It's in the tenths place. So the 0 is in the tenths place. We would say we have 0 tenths in this number. What place is the 6 in? What place is the 6 in, Sierra? That's in the hundredths place. Hundredths. Notice all of these behind the decimal point are ending with a TH, aren't they? TH and then S. So 6 hundredths is what that stands for. How about the 2? What's that? What place is the 2 in? Derek?
Thousands.
Thousandths. The thousandths place. Thousandths. So we have 2 thousandths in this problem. Okay. What else do we have? Well, we have a 5. What place is the 5 in? Okay. 10 thousandths. Yeah, the 10 thousandths. So 10 dash thousandths. So we have 5 10,000ths going on in there. So if we added all those numbers together, 3 ones plus 0 tenths plus 6 hundredths plus 2 thousandths plus 5 10,000ths, we would have that number 3.0625. But here's the deal. We're going to learn how do we read that properly. How do we actually read that properly? So the number 3.0625 is read as 3 and, in other words, the decimal point gets replaced with the word and. Put a decimal point there, right there, that and. 3 and, so just so you know, this is wrong when people say this. 101. That's wrong. Because and always stands for the decimal point. So it's 101, not 101. And is a decimal point. So 3 and, well, here's what we're going to do. We're going to look at this number right here. That's 625. And we're going to look at what's the last place value represented in that. What is it? Wait, 10 thousandths.
Darian Lafferty to the senior high office, please. Darian.
So that's how we show somebody that we know decimal numbers. We read them correctly instead of saying, oh, that's 3.0625. You show up and you say, that's 3 and 625 10,000ths. So any questions on that? This is a random sideline then. I want to see if you guys can tell me what this would be. 4, you don't have to put this in your notes because it might confuse you. 4.27, what would that be? What would that one be? Everybody think about that. What would 4.27 be read as? If you want to show somebody how, like, how smart you are, you'd be like, no, it's not 4.27, it is, what? Paikia? Yeah, it's 4 and 27 hundredths. because it's 27 behind the decimal point, and the 7, the last digit shown, is in the hundredths place, so 4 and 27 hundredths. So it's going to be so cool when you can show people that you know how to read decimal numbers. Anybody have questions on that before we move on? Why are you looking at the clock? Does the clock have questions? Okay, good. I'm afraid it was going to start talking to me. Okay. 3 and 625 10,000ths is the decimal name for, so let's circle this. Oopsie, I need a pen. This 3 and 625 10,000ths is the decimal name for 3 and 1/16. Did you know that? You did not. Well, now you do. Look at that. Okay. Well, how are we going to prove that they really are the same value, they're at the same location on the number line? How are we going to prove that they are? Well, first of all, we're going to take that 3 and 1/16 and write it as an improper fraction. Remember how to change a mixed number to an improper fraction? What do you do? Okay.
Take the denominator times the whole number and then add the
Yeah, you take the denominator 16 times the whole number 3 and you add the numerator. Okay, well, what is that? What is 16 times 3? 48. Add 1 to that. 49. So since that equals 49, what would be the name, the improper fraction name for 3 and 1/16? 49 what? 16ths. Yeah, 49 16ths. So we right now have two different names for 3 and, besides the 3 and 625 10,000ths, we have 3 and 1/16. We have 49 16ths. They're all at the same location on the number line. Well, let's just check to make sure. You don't just trust me on this, that 3 and 1/16 is. I want you to make sure that it is. So on your calculators right now, does anybody know how we would change that decimal 49 over 16 into its decimal name? That fraction, 49 16ths into its decimal name? What do? Sam? Divide. So you take 49, then you take the numerator and divide it by the denominator. So let's do this. 49 divided by 16 equals, and maybe we're going to have to come down here and write what it is. Put that on your calculator and see what happens. Is it 3 and 625 10,000ths? Yes or no? Yes? Yes. Okay, thanks. So I wasn't misleading you when I said that the mixed number name for our decimal is 3 and 1/16. Well, now we got to decide where it's located at on the number line, because that seemed to be an issue, didn't it? Okay. Where do you think that's going to be on the number line? Well, give me a general area first of all. It's kind of like, if you're telling somebody where somebody lives in town, you say, do you know where Shopko is? You're kind of like getting into a certain area of town, aren't you? Okay, and then maybe you'll go from there. So right now I want you to get into a certain area of the number line where we should be zeroing in on. We should head to. Holly? So yeah, so we need to be 3, between 3 and what? 4. Okay, we gotta be somewhere between 3 and 4, don't we? Got to be somewhere in this region right here. Okay, so it's got to be somewhere there. Okay, well, what can you tell me? What are all the markings on there? What is it going by in between 3 and 4? What does each marking represent? How much distance does each marking represent? This is important that we understand, because not every number line is written the same. It's represented the same. So what do you think, Jerry? Is it 1/4? Everybody agree? Are there 4 equal sections between 3 and 4? 1, 2, 3, 4. Why, looky there, there are. So it's divided into 4. So then this particular one would be 3 and 1/4, wouldn't it? Right? And this one would be 3 and 2/4, which is 3 and 1/2. Oh, which, by the way, when we change it to its improper fraction name, 2 times 3 plus 1 is 7. So 7/2. Look at there. Look at all those different names for that spot on the number line. And then what would this one be? 3 3/4. Okay, well, I think it would be a good idea. We know that another name for our decimal is 49/16. I'm thinking it might be good to have 16ths. Now, we don't want to have to divide it into 16 equal parts, but could we rename each of these places here? We're just going to zero in on this part. Could we rename those as 16ths? I bet we could. Let's see. 3/1 would be the fraction name for 3. So let's come down here and say, what would 3/1 be as 16ths? What would 3/1 be as 16ths? 1 times what is 16? 16. So then I gotta take my 3 upstairs times 16 also. What is that? Danny? 48. Oh, well, there's another name for 3, also known as 3/1. We can also call it 48/16. Yes, Danny? It's 49. We were just renaming 3/1, so it is 48. 3/1 is 48. Okay? Let's take this 3 1/4 and rename it first as its improper fraction name. What is 3 1/4 as an improper fraction? 4 times 3, class, is? What? 12, and 12 plus 1 is?
13.
So this would be 13 what? Fourths. So here's another name for 3 1/4, 13 fourths. Did you ever think you could, really get so many different names to just one spot on the number line? Well, but remember we want 16, so now we're going to take this 13 fourths and we're going to say, what would I have to do to get that renamed as 16ths? Now what do we have to do? So, what do you have to take times that 4 downstairs? 4 times 4. We do that downstairs, we got to do it upstairs. Okay. Anybody know what 13 times 4 is? Or does your calculator? How much? 52. Okay. Also, now we just said 13 fourths is really also the same as 52/16. We're trying to locate what number again? How many 16ths? 49/16. Do we need to worry about any more? Would our 49/16 live somewhere between these two? Wouldn't it? Which one is it going to live closer to? The 48 or the 52? Harley?
49.
We want 49, so is it going to live closer to 48? It's going to live closer to the 48. In fact, it's going to be, so 48, 49, 50, 51, 52. So we have, we're really close here. So we're going to say, you know what? I think it's right here. Here's my 49/16. Also known as 3 1/16. Also known as, what's its decimal name? What's its decimal name? 3 625 10,000ths. Okay, good job. This is really, really important. We cannot make sense of math if we cannot make sense of the number line. So if you're not understanding this, you need to get some extra help, okay? Because we have to understand the number line to be successful in math. It's just, when my daughter, who has small children ask me, Mom, how can I help my kids become better math students? I said, just keep talking about the number line. Keep working with the number line. That's the most important thing. Okay, questions, anyone? Right now. Okay, let's go to the back side. Okay, you get to use your calculators. But first, before we do that, we're going to show what we're going to put into our calculator. We're gonna now tackle the learning goal writing fractions as decimals. So remember, to write a fraction as a decimal, what do? Divide the numerator by the denominator. So this first one's going to be 4 divided by 5. Tell me if I'm right.
Yeah.
Alright? Okay. Let's try the next one. What divided by what, first of all, on your papers? 7 divided by 8. And now you can use your calculator now that you wrote that down. Okay, I'm going to put up there what I think it is, and you tell me if I'm right.
Yeah. Yeah, you're right.
Oh, okay. Well, let's read these numbers very quickly in your class. What number is that? 0.8.
Yeah.
Yep, 8/10. What's this one?
875,000.
875,000. You guys are good. Okay, next one. 2 divided by 3. By the way, do you always start with the numerator? Yes, yes, yes. Yes, yes, yes. 2 divided by 3. What happens this time? 0.6 repeating. Tell me if this is happening on your calculator. Something like this. I don't even know how many times it just takes it out, but anybody got that on your calculator? Something like that? Yeah? At the very last digit on your calculator showing is the 7. Did yours put a repeating bar over it for you? Otherwise it should be doing that. Okay. Why is there a 7 at the end if this is a repeating 6? That's interesting that yours doesn't do it. It must be a multi-minute setting. So tell me, why, anybody think they know why there's a 7 at the end instead of a 6 if this is supposed to be a repeating 6? Because this is really the correct answer, so let's put that one. Anybody at this point think they know why? Okay, we'll explore that later then. Okay, now I want you to do some critical thinking. No calculators on this one. No calculators on this one. If 2/3 equals what we just got, fill in the blank. If 2/3 equals that 0.6 repeating bar over the 6, 6 is repeating forever, what do you predict 1/3 is? Put something in your paper. You're going to erase it after we talk about it. Predict. What do you think 1/3 is then as a decimal? No calculators allowed right now. If 2/3 is 0.6 repeating, what do you predict 1/3 would be? Got it for me, Sylvia? No? Yeah. What do you predict? Hmm? You say something? Do you want to predict? She has a 0.3 with a repeating bar over the 3. Anybody else predict that? Well, yeah. That is what it is. If you put it in your calculator right now, if you actually did 1 divided by 3 in your calculator, let's see if that's what you get. You get a 0.333333, and they just keep going, right? How did you make that prediction? Carly? We remember we didn't want to divide it out. We just wanted to predict based on the fact that 2/3 is 0.6 repeating. Why would this is important. This will help you with other fractions and other decimals. Believe it or not. Why did you predict that? Oh, she's she says if 2/3 is 0.6, she divided the 0.6 by 2 because 2 divided by 1, or if we have 2/3 and we divide that in half, wouldn't that be 1/3? Isn't half of a 2/3 of 1/3? And half of 0.6 would be 0.3? Yeah. So it's important that we understand, maybe too, that we can sometimes not even have to just count on the calculator being right, but we understand why the calculator got that answer. So questions on changing from a fraction to its decimal name. Okay, then let's go to our last learning goal, which is writing decimals as fractions. 0.15. How does that read? Okay. 1500s. You know what? We're going to say 0 and 1500s. Okay. Or, you're right, we could just read it as 1500s. But that 0 really actually has a role in that. It's saying there's nothing, this number is less than what? What is this number less than? Danny? 1. Yep, this number is less than 1. There's nothing in the ones place, it's a 0. Okay, so then, if this is 0 and 1500s, or as Kate said, 1500s, I think it was you, Kaden, right? How can we write that as a fraction? 1500s. Kaden? 15 over 100. 1500s. 15 over 100. Well then, does that simplify? Can we simplify 15 over 100? Because I'm pretty sure that, they probably want you to simplify it. So let's see, what goes into 15 that for sure goes into 100 also? 10? 5. If the numbers end in 5 or 0, you know they're divisible by 5. So 15 can be divided by 5. 100 divided by 5. That's 15 divided by 5. Carly? 3. Wait, what's 100 divided by 5? 20. What do you think? Can we simplify it anymore? Okay, you're convinced this is as good as it gets? In other words, there's nothing else that goes into 3 that would also go into 20? Okay, and we would say the fraction name for 0 and 1500s is 3/20. That's its simplified fraction name, isn't it? It also has this fraction name, 15 over 100. It's just another name for it, not simplified. Okay, so let's do this one. This time I'll let you just leave off the 0. What does this read? Carly?
125.
Which one do you want? Thousands. Okay, I'm going with that one then for now. 125 thousandths, she says. Do we agree? In other words, is the 5 right here in the thousands place? Yes or no? No. Okay, well then what place is it in? This is what? Tens. This is hundreds. This is? Oh, I guess we're going to go with thousands. Okay, well then that means we can write this as a fraction of 125 over 1,000. Thousandths. 1,000. How do you feel about that? Do you think that can be simplified? Yeah, they end in 5 and 0. What are they both divisible by for sure? By 5. So 125 divided by 5. 1,000 divided by 5. Anybody know how many 5s are in 125? Wait. No, that's too many. 3, 25. Anybody know how many 5s are in 1,000? How many games? Sam? 200. Okay? Is that simplified enough? Wait a minute. They both end in, they got a 5 and a 0. Wait a minute. That means what?
We can still simplify more, so we have 25 over 200. They can both be divided by 5 again. 25, how many 5s are in 25? 25 divided by 5. 5. 200 divided by 5. Class? 40. Can it still be simplified some more?
Yes.
Oh my goodness. Are we ever going to get to quit? 5 divided by 5 is? 1. 40 divided by 5 is? 8. Oh, we found it. The decimal 125 thousandths is another name for 1/8 and vice versa, right? Okay, so again, we're going to make sure that we know how to rename our numbers. We're dealing with decimals and fractions. So questions on this last section, last learning goal.